HVAC 360 is brought to you today by batteries. From the thrill of licking a 9-volt as a kid to desperately blading with a dying phone, batteries charge our lives with both joy and sorrow. Frankly, we have yet to meet a clock that won't tell us the time. Why? Well, we have ways of making them talk. Batteries. You can never have too many of them. Please recycle responsibly. Hey, what's up? Welcome back. This is episode number 88. I'm Matt Nelson, host of HVAC 360, helping you go further and faster in the field of HVAC. Listen up to hear stories, industry experts, and more HVAC knowledge than you can shake a stick at. Those of you who are new here, definitely go out and subscribe to my newsletter at HVAC360.com, and you'll get weekly bonus material delivered right to your inbox. So what's up for this week? Well, it's a good one. We have our first repeat guest, yay, as I talk with none other than Paul Torsellini of the National Renewable Energy Labs. This time we're going to be talking about net zero in K-12 schools and the newest ASHRAE Advanced Energy Design Guide. So let's cut to the tape after a brief word from our sponsor. All right, today our guest is Paul Torsellini, who is the Special Projects Chair for the Advanced Energy Design Guidelines that ASHRAE is putting out. He's also a Principal Engineer at the National Renewable Energy Lab, also known as NREL. How you doing today, Paul?
Good, and good to talk to you.
Yeah, no, excellent. You are the first two-time guest that I've had on this podcast, so it's really exciting that I get to talk to you again. Let's say, as far as let's talk about the ASHRAE's newest, and it came out in January of 2018, so earlier this year. If you're listening to it in real time,
January of 2018, just before the meeting that we had, the big ASHRAE meeting.
So it's the newest ASHRAE Advanced Energy Design Guideline. And for those who don't know, they're completely free. You can download them. All you have to do is register, and then you can get the whole thing electronic. I guess you could buy a physical copy, but you can get an electronic copy free.
Yes, so you can go to ASHRAE's website, and if you want a hard, nice printed copy, there's a nominal fee to get the actual printed version, but you're correct. You can go to ASHRAE's website and download not only this guide, so this is the first in a new series focused on zero energy buildings. Previously, we had done a 30% design guide series and then bumped up to a 50% design guide series. And so now we're hitting hard the concept of zero energy buildings and really trying to show owners and practitioners that it is achievable today, and there are other examples of people doing it, and really leading people through the steps of how to make it achievable. One thing about these guides, and they are guides, they are not codes, they are not standards, so they're not kind of a mandatory language, written in what's called a mandatory code language. And they're also, ASHRAE also has all these guidelines out there, which kind of are on the path to some of the codes and standards. But this is actually a guide, and really providing that kind of guidance to practitioners.
So, what was this a conscious decision? Now, this is for the K through 12 schools. We haven't mentioned that already, but is this a conscious decision for all the advanced energy design guides to be, because I guess the last set, they released kind of a set that was the 30%. They released an entire set, covering, offices, small hospitals, different kind of building types. And now are they just going to go for the net zero? Is that going to be the next kind of, you're not going to see a 75% or anything like that. It's just going to be a net zero design guide across the board?
That's correct. So, it's really kind of the third series on zero energy buildings. In fact, we've set up the project committee, and we're going to be underway very shortly here on zero energy offices. Will be the second in the series. So they are they're a collaborative effort. So there's a number of people to help make these decisions. So you've got AIA, ASHRAE, U.S. Green Building Council, IES. Are the major partners, and the U.S. Department of Energy provides a lot of the funding to make this happen. And then we at the National Lab are also funded to provide kind of the technical support. And one of the things with the guides is that we do simulations. And so one way to think about any of the design guides, but certainly the one that's out now, is that we have done the modeling on some prototypical buildings to actually show what kinds of technologies can get you to zero, what kind of strategies. So when you start, you actually have a prototypical building that we know can achieve zero in the climate zones, and that's what we're writing about. So it's not just a bunch of ideas. It actually has been vetted with energy simulation and modeling to kind of prove that we can do it.
So these design guides, they're as far as the usage of them, they obviously they're based on the real data, like you said, the actual energy calculations. So I guess what is contained within these design guidelines?
So the guidelines start off with kind of a message to owners. So you could read the first part of the guide as an owner. In this case, it would be kind of a school board or school administration. And the idea is to say, oh, there are other people doing this. It is an achievable concept. I want one of these. And it gives some ideas to owners on how they could go about procuring one of these guides. We feel that one of the most important steps here is that owners need to ask for design excellence. And they need to set some measurable goals, right? If you're a district and you've got a school district and you've got a certain amount of money to spend on your school, which is usually defined by kind of historical averages, maybe state requirements, at the end of the day, usually a bond issue that's going to pay for this. You know how much it's going to cost. And we really want people to set goals around that. And zero energy is kind of a nice goal to go after. It has some market traction. People kind of understand that balance between supply and demand pieces. We then go into a discussion about kind of what is zero and help people grasp what that does mean and how do you do that calculation around that. Like I said before, we talk about the procurement process. We then talk to engineers and architects on how would you approach even responding to this kind of procurement. What kind of modeling would you do? How do you start putting the pieces together? How do you start looking at the massing and the strategies? And then there's a whole section in the guide that is very consistent with other guides that we've done previously that are really how-to tips. And they're a list, kind of just a long list of strategies, and in this case, things that will help you get to zero. It doesn't mean that you need to do all of them, but there are certainly things to consider. One of the things, and partly because of the way a lot of schools are designed, typically do have architecture and engineering firms, this was really geared towards, get those ideas on the table, and get your design teams to model them and show that you can hit these goals. Also with those strategies are a lot of, kind of challenges and things that, kind of lessons learned, things that you want to avoid to actually make things successful. Things like if you're going to use daylighting, then you want to deal with the glare. If you install a daylighting system and people still want to turn on the lights, in a lot of ways, the daylighting system has failed. You haven't accomplished the ability for lighting to really offset and make people comfortable in the space in terms of their lighting needs. I often say, well, I can take any building and make it zero. I'll just disconnect its utilities today. And that gives you comfort and other service issues. Well, you want the building to be comfortable. If the building is uncomfortable, again, that's an issue in how things were designed and operated. And you should be willing to address it. And so we get into a lot of those topic areas in the guide.
So now I think the guide for like 50% energy efficiency was set up generally speaking the same way. Is that correct?
It is, yeah. So there's definitely a lot of mirroring going on, and you'll see some overlap, right? Because having a good thermal envelope in a 50% school, you also want a good thermal envelope in a zero energy school. We did add, one of the things that has changed, we try to keep up with kind of the trends and technologies. Like on the envelope section, we now talk about envelope testing and performance testing of that envelope, so that when people build it, they've got something that they can hold contractors accountable to make sure it's going to perform the way the design wants it to perform. And so we give some guidelines around that.
So, and I guess the differences between 0 and 50%, where I mean, if you had to pick a couple, what would be the biggest differences between the two guidelines?
So the original one was 50% from ASHRAE 90.1, 2007-ish time frame. The current one, we did an analysis and it showed that it's about 40% better than 2016, ASHRAE 90.1. What's interesting about that is that all technologies are getting better. And so as we want to keep ahead of those technologies. So things like, lighting technologies, right? I mean, the concept of using LEDs and controlling LEDs and highlighting areas that you really need to light has really lowered lighting power densities, or the ability to lower those while maintaining good quality lighting. We've gotten much better at specifying envelopes and what they need to look like. We did go into quite a bit of detail this time on thermal bridging and kind of the constructions of the envelope. And then on the HVAC side, a lot has happened in the hot water heating space with heat pump hot water heaters, even just using heat pumps in general, whether they're air-based or ground source-based. Those have come a long way, and especially starting to get into some of the lower temperature regimes, so in colder climates, these systems being successful. So you'll see those kind of increments, in all the areas. One of the big differences is there is a section now on photovoltaics. And, how do you apply the PV to the building and some of the cautions and things with that. We did, a lot of people say, well, I can't install PV, maybe it doesn't work utility-wise, or I have a limitation on how much I can install. So we do talk about this time being zero energy ready and provide a set of EUI targets for the building without the renewables on it. So you can think about it as how efficient does the building have to be such that renewables could meet the load, either today or in the future. So those pieces are all discussed here also.
Right, and that was one thing that I liked when I looked through the design. You kind of mentioned that obviously, when you talk about 30%, 50% more efficient, it's relative to some code, some ASHRAE 90.1 code. Now it's kind of, hey, you know what? It's net zero, and here's the EUI. So we've kind of transitioned away from kind of being relative, more energy efficient relative to a benchmark, to having a benchmark of 0 and saying, hey, what is your energy use intensity for this building?
Yeah, absolutely. I think that having an absolute number that gives people something to target, first of all, it gives design teams something to focus on. if you talk about percent energy savings, design teams then have to spend a lot of time focusing on, well, what is that benchmark, right? And establishing the benchmark doesn't help you save any energy. So having those absolute targets that we've already put together, and like I said before, we can compare those with the official determination of energy savings for ASHRAE 90.1 2016. We can reference those points, and it's already been that work has already been done, and so you can have good confidence that having those EUI targets, you can meet something. I think the other value of having a zero energy building is just from a communication point of view, the idea that you're going to produce as much energy as you consume, I think has captured, maybe I'm overextending my role as an engineer, but I think it does capture people's imagination saying, oh, I am now supplying all of my own energy. I'm so efficient that I can meet my own energy needs. As opposed to saying, well, this building is 30% better than some hypothetical building that I'm never really going to build. And so I just think from a general kind of audience and sharing and getting people excited about it, the zero energy concept works much better.
Yeah, no, absolutely. And I guess from a personal standpoint, I really got excited about when I saw the Advanced Energy Design Guideline come out, and I think I noticed it in probably like February or something like that. But the district that I live in is planning on building a new school. So I'm like, this is perfect. I'm like, because I'm like trying to look for some of the, the tips and tricks and what we could actually communicate to the board to help them understand. And, obviously having this EUI kind of goal really is something that, hey, just put that in the requirements of this building, and if you meet that, nothing else, even if you don't use the PV, like you said, because obviously the net zero is building is essentially a low energy building with renewable energy. So there's two components to it. And even if you don't get the photovoltaic, and even, obviously technology is getting better and better all the time. Even if you wait a little bit on the PV, if you're solar ready, then boom, you've got it controlled. You have that EUI benchmark. So I was really excited on a personal level to see that design guideline come out to say, hey, you know what, we could build a really special school, instead of just remodeling some schools from the 1950s and 1960s.
Well, and people are doing that, and one of the things that and there's all kinds of different kind of bandwidth in or kind of appetite for some of this, that kind of one would say, somebody would look at this and say, I'm going to use a performance-based procurement methodology where I'm going to set a set of goals, and I'm now going to interview the teams based on their ability to get to my goals, and let the teams kind of bring it to the table, and the owner selects the best team to do that. I've also seen where architects look at a building budget and just from a kind of a competitive advantage will now go in and say, I've looked at your budget, I've looked at the timing and the schedule, and if you hire us as the team, we will deliver you a zero energy school. And then, are using the guidance. So more and more architecture firms are in a position to do it. I think what really helps is that at minimum, school districts should just entertain the idea, saying, when you respond to this request for proposal, talk to us about the ability to get a zero energy school, which from a school district point of view has a very low kind of risk associated with it, but at least it gets the dialogue started. And then you can dig into the details about what that means and EUI targets and things like that. But I've been told that in some of the, especially the major cities, that if you put something on the street that says this, that you'll have several architecture and engineering firms now ready to deliver a zero energy school, but they don't always want to do it because the client hasn't asked for it. So just getting owners to ask for it's a big deal here.
So yeah, and I think that's total. I think it's an education that we as engineers need to get out there, and that there are easy things that you can ask for as an owner, that it doesn't take a lot of understanding. But the net zero concept, I think, is very easy for anybody to really understand. Now, I guess the one question, and you kind of alluded to it already, is cost. I mean, obviously, cost is, for a school district, operating cost is one thing, but the construction cost through a bond issue, there's really no leeway. So I guess the one interesting line that I'll pull out of the Advanced Energy Design Guide was that there was a net zero within a typical budget, was something that was kind of laid out there, and that was really attractive to me. So I guess what would you say to somebody who says, you know what, net zero, that's nice, Mr. Owner, but we really can't get there on your budget?
So that is an excellent question. And you brought up an interesting point that most of these are kind of a fixed budget. And, many of these projects, I even see, design dollars going into things like, well, if we upgraded to a new chiller, then the payback is this, or the return on investment on this is this, or life cycle cost. The problem with thinking that way is that if you're already at your limit dollar-wise, doing the analysis doesn't make more money. It doesn't bring more money into the project. And so you are kind of stuck with this fixed upfront capital. And so I like to shift the problem around and say, okay, here's the fixed amount of money. Here's a prioritized list of goals that we want. And when you're interviewing teams, go down that prioritized list of goals, which could include amenities, could include energy, and let the design team figure out how to do those trade-offs. The most effective design team will figure out how to bring multiple things together, in order to get kind of this holistic package, that we put so much insulation in the walls that we can downsize our cooling system and save on HVAC costs, or that by having good effective lighting systems and daylighting systems, we don't generate the heating, and therefore we don't have the cooling sizing. Really putting the pieces together, right? And you want the creativity of the design team to do that. So as an owner, how do I unleash that creativity to make that work? What we're finding is that cost is a lot of times is an excuse to not do something. And yet people spend money the way they want to spend money. And you go through a building and you say, well, why do I have these huge glass facade walls? Because they cost more than, regular insulated steel stud walls. Well, because somebody wanted them there. They wanted that amenity. And the question is, does that help us energy-wise or hurt us energy-wise? You end up with curved walls in a lot of these buildings. Well, it's harder to build a curved wall than a straight wall. And so we make decisions, and a lot of those decisions don't get cost justified. And what we want people to do is to think about all of these elements together and then find design teams who can put all the pieces together and hopefully not cost extra money. Or if it does, that value is very clearly articulated and something else has less value and leaves. So, I often use stories, things like, people pay a premium for aluminum alloy wheels on their car. Does that make the car go better? Or how many speakers are in your car? The more speakers, does that help the car go better? And yet, so we spend money on these things, and we do it in buildings every day. And somehow we have to get those aligned with making the building energy efficient at the same time. And that's the ultimate success.
So, obviously, when you look at the net zero energy, and you're kind of referring, when you're talking about the RFPs going out to, architects and engineering teams, and a lot of them, they want this, this project, this jewel in their portfolio of a net zero building. So they're gonna provide the best thinking. Isn't with ASHRAE coming out with all these advanced energy design guidelines at net zero, isn't this really becoming the new standard? Shouldn't buildings really be hitting that EUI that you've kind of established as a good benchmark?
So my opinion on that is absolutely yes, right? That we know that we can achieve these kinds of energy targets. And one of the things we didn't mention earlier about the design guide is that there are case studies in there with actual measured data that show that these kinds of EUIs are achievable. So sure, it should be the standard. Now, making the market move there overnight, markets always push back on things. But you'd hope that people realize this is achievable, that it really doesn't, have to cost extra money if it's well integrated, and that the market should move in this direction. We're constantly trying to strategize what those are, trying to understand, what the barriers are. I'm always happy to hear people's barriers and strategize ways, to get around those things. But the more people that do it, obviously, you get more and more momentum around this.
So when you talk to designers, really, what is, I guess, what's their biggest hurdle to being able to get a net zero energy building?
I think a lot of it is awareness, and trying probably after, just that this is achievable, right? That you can make this happen, and more design teams are realizing that every day. And like I said before, using it as a market advantage, to help them, put these buildings together. You have to keep up on what the current technologies are. You mentioned earlier something like, well, I looked at this and, it didn't make sense to me. Well, if you looked at it 3 or 4 years ago, technologies have changed dramatically, right? Especially looking at lighting technologies, some of the heat pump technologies, and most importantly, the cost of the solar going on rooftops has just plummeted in cost. And so if you looked at it a couple of years ago, you really need to look at it again. And like I said earlier, as an owner, if you don't think it's achievable, at least put the words in your RFP and see what comes back. You might be pleasantly surprised of what comes back. I think that there's more and more capabilities every day around doing energy modeling and using models as a design tool to help make decisions around buildings. And so that is, more readily available. The more, architects love to kind of get inspiration from other examples. And so there are more examples coming on every day that I think help with that. There's also a lot more data around things like what the plug loads should look like or could look like, and how to build better envelopes. I think the engineers, they don't want to call back and saying their building is uncomfortable because the insulation wasn't properly installed. And so they tend to want to over-design these systems a little bit. And, if you have more confidence in the rest of the quality of construction, the oversizing, does not need to happen as much. So, there's a lot of, players here, but I think it's just overall awareness and just having some confidence that you can really make it happen.
So is there anything, speaking of players in the team, obviously when it starts getting built, if they've specified it well enough, is there anything that the contractors need to know? I mean, how do they need to change doing what they do for a net zero building?
So I think it's really important that that the appropriate metrics and controls are in place up front, around the quality of what's going in. Obviously, you've got to be able to install, ductwork and not have it leak. You need to install, electrical lighting systems and have the controls work properly to respond to daylighting. You need to have a good envelope, and those are mainly site built, and so there needs to be a certain level of quality control that goes into that. And things like envelope testing, basically a large scale blower door test to quantify how good that envelope is, and that can be specified today. And that, again, contractors are figuring that out if they want that kind of work. I talked earlier about performance-based procurement. One of the ways of doing that is to do it as design build, where you competitively select the entire team, starting with the contractor, who then is obligated to meet certain performance requirements. And then they control the whole process from design to purchasing, all the way through. Yeah, we talked about cost earlier. One of the things about cost is that you can hire all kinds of estimators. Every estimator says they've got all the right answers. At the end of the day, the only real cost is the cost that the contractor pays for the goods and services. And they negotiate those things every day. And that's, part of what their business is. So they really are the ones that are responsible for containing the costs at the end of the day. And having it design build, if you do it properly, you can kind of manage all those in one place. And there's one person who's ultimately responsible for delivering the product, in this case, the building, on time, on budget, and meeting your performance requirements.
Excellent. Now, obviously, with the owner plays a important role up front. We've talked a little bit about that. What about in the back end? What about maintaining, and making sure that you really follow through with what you've asked for?
Yes, you need to definitely do those things. But I think there's some important pieces up front. Especially in the schools market, I see a lot of people that are delivered a building that they don't understand and they don't know how to operate. I can take every good design intention and it will go bad if somebody doesn't know how to operate it or make it run smoothly. You can kind of put it in terms of take most of the population today and have them try to drive a standard stick automobile, right? And it often can be a bad experience, right? Because they don't know how to operate that device. And the same goes with buildings. And I think one of the things that owners need to be very clear with up front is their level of knowledge and willingness to, engage in operating a building. It may be, an example might be a very small school district where the custodial staff is also the building operator. And you might want to use programmable thermostats in that environment as opposed to an energy management system. The level of, that's really important, that the people who get the building know how to operate it at the end of the day. And they're trained to have some comfort with it. Because if they don't understand it, they will bring it to a level of their understanding, which usually is not a positive sign in most of these buildings. So it's up to the owner to specify what that is, and then it's up to the design team to make that happen.
Yeah, no, absolutely. I like your manual transmission kind of analogy. It's essentially the maintenance staff is going to try to find first. Once they find first and get it in gear and get the building moving, they're going to just leave it in first, no matter what
right.
The penalty is.
That's right. And even things. I kind of have this philosophy of start with lighting controls. If it doesn't look like an on-off switch, people don't know how to control it. Now, you can put a lot of intelligence behind that on-off switch. and you can go to kind of a vacancy system where you have to turn the switch to the on position or hit a button that's very clearly labeled as on and the lights come on. And then if people want the lights off, they very clearly hit the off button. And maybe the smarts behind it is if they forget to turn off the off button, you've got some kind of sweep control that turns off the lights. That's a much more maintainable system than, say, a building filled with motion sensors that people are trying to calibrate or figure out how to get working properly, or false triggers with that. And again, that's, and for some, motion sensors might work well if they can understand that. For others, it needs to look like an on-off switch. And, especially in transient environments where you have lots of people in and out of them. I think your other big success here, and I've seen it work really well, are effective dashboards and engaging the students as part of this and the educational process as part of this. There are some of these schools out there where the students give the tours for the energy features, that the students are examining energy data as part of math classes. And having people looking at data and engaged will help, figure out where there are issues. And so it becomes part of the learning environment.
No, that's really fantastic, especially when, obviously when people are building a new school, and it's no different from my school district, they want the 21st century learning environment, so they want the best. So giving them, any extra tools for the teachers to use, that's really the biggest bonus you can do, because obviously the teachers are the asset in the school district that you want to, foster, encourage, grow, and you want to give them kind of an environment where they can essentially, play with the children and get them to learn the most they possibly can.
Well, and that goes back to well-lit environments, good daylighting, not having glare and that level of distraction. I hate it when people put in windows in buildings and pay for windows, and then people put in blinds and close the blinds all the time, right? Why have the window? Or the window was not designed appropriately to work with the space. And so absolutely, engaging the teachers as part, they should have, healthy, happy, energy efficient environments that they can be proud of.
So now I'm involved in commissioning, as most of the listeners know. But have you ever had a net zero building that you didn't commission? So
that's a fascinating discussion, because going back to the car analogy before, is how many people buy a car as a entity and drive it off the lot, and their first stop is a commissioning agent to get the thing working correctly. That wouldn't happen, but it happens every day with buildings. So I think, kind of my idealistic world is that the commissioning agent role shifts to actually being a part of the design team, right? How do you design elements into this building that need minimal, commissioning and still work? If you get the envelope of the building right, and I can reduce the amount of HVAC, in some ways that's less to commission. Those passive strategies will always work for you. We just talked about light switches, right? If I can get the lighting controls right, you shouldn't have to go back and commission all these motion sensors. It's an interesting role. Now, in general, what we find, and again, I think this is new, and a lot of these buildings do by default have some kind of, especially an owner's rep that's doing the commissioning, but that's important. But if you also go back to where we were talking about performance-based commissioning, if the contract says that the building must operate at a certain EUI, then maybe the commissioning agent is now working for the contractor because they're on the hook to make it work that way. So I think the role might shift a little bit. I think you always have a need for somebody kind of doing quality control and checking. And I think the commissioning agent is, perfectly aligned to do that. But ideally, you would have a building delivered to you that works, that out of the box should function. And that all of that work and quality control has gone into effective design and effective construction.
Fantastic. All right. So, Paul, I appreciate you taking the time talking with us. I guess one of the last couple of questions that I had for you was these Advanced Energy Design Guideline publications. We're at net zero for the K through 12. Is that really the end of the line for what I guess what we're doing here? Obviously, you've kind of alluded to other net zero publications that are coming out, but are we leaving it here? Is that net zero for K through 12? That's it for this lineage.
Yeah. Well, I guess you could, one way to translate that is to say, if all buildings become zero energy, have we solved the energy problem, right? And at that point, you'd say, well, maybe that is the end of the road. One of the things that I've noticed is that kind of the max tech of what is achievable always seems to be at about 50%. And so as time goes on, you can always do better than we had in the past. What that might mean is if you're still trying to achieve zero, maybe you end up with a smaller percentage of rooftop photovoltaics. But when you look across the sectors, the commercial building sector in general, you very quickly realize that there are a lot of buildings that cannot get to zero, right? High intensity uses. Tough ones are things like fast food restaurants, hospitals, healthcare, high-rise office buildings. But then there's other buildings that typically are, 1 to 3 or 4 stories, right? Things like schools, small office buildings, warehousing is a big one. And in reality, those building types really need to long-term be net producers such that you have some place to send the energy to these buildings that are not going to be able to achieve that goal. We did a study several years ago that looked across the entire commercial building stock, and our conclusion is that, yes, we need about a 50% energy savings, and if we cover the roof of those commercial buildings, we as a community of buildings could get to zero. So, the next step might be, districts, a couple of city blocks or a small community. What does it take to get those entities to zero? Which buildings can get there and can help offset the energy from others? And those are still a little bit out in the future, but we're starting to see interest around that, those pieces.
So net zero districts. So they're gonna start, grouping together and building that. That's some fascinating stuff there to make sure that you have net positive.
Yeah, we're actually working with some districts along those lines and looking at the optimization and the synergies between different building types and how they can help one another. You might have something with a large process load, maybe, a data center. And the question is, how can I use that waste heat in a nearby building, right? Instead of just throwing it away. How do I get heat recovery out of maybe my sewer waste system and put that into a heat pump that I can then use to help heat buildings? And there are certain things that you can bring, multiple buildings together and get those synergies that you don't get with an individual building. And so there's some pretty exciting work going on with that now. And, what those optimizations are starting to look like, how those interact with utilities and microgrids and helping with resiliency issues on the utility grid. All those things are starting to feed into kind of this district or small community environment.
All right, fantastic. So, Paul, any last thoughts that something we might not have covered?
I would say download the design guide. Let us know what you think about it. For your audience, let us know what your barriers are, so that we can continue to kind of improve on these things. And most importantly, anybody that's taken the time now to listen to this, what is your next step? What are you going to do with this information? And you mentioned your own school district. What are you going to do personally in getting energy goals into your school district as an owner or as a citizen, as a design professional? Can you move your kind of business line to saying, what if we just start delivering zero energy buildings? And we use that from a marketing point of view and as a competitive edge. We want people, to do these things, and ultimately it's, all the decisions of your listeners that will make it happen, right? It's not something that I can necessarily say. I can provide some motivation, technical content, but ultimately people have to do something with this.
All right, fantastic. Well, I appreciate the time, Paul. Thanks for talking with us.
You're welcome, and thanks for having me.
All right. Thanks again to Paul Torsellini for taking the time to chat with us. Check out the show notes or links to things we mentioned in the interview, and you can find those show notes at hvac360.com/88. Well, that's it for this week. Thanks so much for listening. I hope it was helpful. If you know anybody who's looking to get into net zero design, and really who isn't, why don't you go ahead and share this episode with them? It increases your value of your connection with them. And also, as I mentioned at the top of the show, please subscribe to my list if you haven't already at hvac360.com for more information and weekly updates. And if you're so moved, it would be a great honor if you would consider leaving me a review and a rating on iTunes. That's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you go further and faster in the field of HVAC. And as always, know what you build and share what you know.